Okay, so this is the video for section 22A, and in this section we're just going to rewrite some equation in vertex form, and when we rewrite it in vertex form, it easily allows us to find the vertex of a function just by looking at it. Okay, so if we do this here, this is just our warm-up. We're going to go ahead and plug these x values into this formula here and get our y values, okay? But I'm going to show you a real quick way we can do that that's a lot easier. All right, so if you go to your calculator, your TI-84, and in your equation, y equals, you put in the equation that we have in our notes. Okay, obviously you can put each x in individually and just pound out the y's, but a lot quicker way you could do it is if you have the equation in here, if you hit second and then graph, see above in blue where it says table, it gives you the values. Okay, so like -2 is 4. -1/2 is, or -1 is the y is 1/2, and so on and so forth. So go ahead and jot those down and then plot the points on that graph. So pause this, jot those down, and plot the points on the graph. All right, so here's your table, and then here's your graph. Hopefully yours is a little nicer than mine, okay? What you can tell from the table and the graph is that it's a perfectly symmetrical graph, and it is a parabola. So we are going to the parent function of the quadratics. So it looks like this. So clearly from the graph and the table, you can see that the vertex of this is at 2, -4. Remember, the vertex is kind of the turning point of the graph. The lowest it goes or the highest it goes. Find the vertical line in a graph so that when you fold the paper, basically we're talking about what makes it symmetric. So if we were to draw a line right here, okay, it's symmetric on each side of this line, or we could reflect it from one side to the other. Okay, and this line just happens to be x equals 2. Okay, so we're going to write x equals 2. And what this is called is the axis of symmetry. Okay, you'll see it as AOS a lot. What is the equation of that line? X equals 2. How does it relate to the vertex? Notice it's the x value of the vertex. So the x coordinate of the vertex. Okay, what is the line of symmetry for the graph with a parabola of this? Now let's think of this in terms of transformations. Okay, we're moving right h and up k. And if all that we're worried about is the x coordinate, then we're worried about the right h. So the graph of this would be x equals h, whatever that h is. And then describe the line of symmetry for this. The line of symmetry would obviously be x equals 1. All right, so this is kind of the big idea for this lesson, and we're going to talk about vertex form. So remember, if we're talking about transformations, okay, this minus h tells me we're moving right h, and this tells me I'm moving up k. Okay, and we're talking about quadratics. So remember the parent function of the quadratics, the vertex is right here at 0, 0. Okay, so if we move this vertex right h and up k, the vertex will be h comma k. Okay, and then of course the axis of symmetry, like we just talked about it, will be x equals h. Okay, that's all this is saying. All right, so if I look at example 1a, okay, I don't care about this vertical translation before here. Okay, it doesn't matter, it doesn't affect the vertex. All I want to pull out is the h and the k. Okay, now notice we want x minus h. Okay, so for this to be a minus, my h has to be a -3. And then obviously my k is 4. Okay, so my vertex here is -3, 4, which means my axis of symmetry is x equals -3. Okay, now if I graph this, I'm going to go ahead and do just a quick chart. Okay, usually on your tests and your quizzes and stuff, it wants you to actually plot 3 physical points and then connect the dots and kind of eyeball it after that. So I'm just going to pick easy ones. So if I plug -3 in for here, we're going to get 4. If I plug -2 in for here, we're going to get 2. And if I plug -1 in for here, we're going to get -4. Okay, now just put those in your calculator. That's the easiest way to do it. And it's easier to find somewhere around the vertex. That way it's not like off the graph. Okay, so I'm going to do that. And now I'm going to go ahead and plot it. Okay, so if I plot those 3 points, guys, okay, remember this is my vertex here, and this is my axis of symmetry. Okay, which means it's symmetric. So that means right here is going to be another point, and right here is going to be another point. So if I connect the dots, forgive me in advance, it's going to look something like this. Okay, now my domain and range, we're going to hit our domain and range hard moving forward. Okay, so remember my domain is all my x values. So if I look at this graph, are there any restrictions in how far left or how far right this is going to be? If I like zoomed way, way, way out and I saw this all the way from -infinity to +infinity, would it ever stop on my x values? And it would not. So I could say it's all real numbers. Okay. And then my range is my y. So is there a limitation on how high or how low this goes? And obviously the peak of this graph in terms of y value is at 4. Okay, so I can say that my y is less than or equal to 4. Okay, now in college algebra, we would have to write this in interval notation, okay, which we would write from 4 to infinity. Oh, to -infinity, my bad. Brain's not thinking. So we'd go from -infinity to 4. So -infinity to 4. Okay, now notice there's a parentheses here and there's a bracket here. Okay, something you need to know in interval notation is this, the parentheses, is not equal to. Okay, so strictly less than or greater than would get this. And as a technicality, we'll never get to infinity. Okay, whereas 4, we do equal 4 here. So this is equal to or less than or equal to, greater than or equal to. So that's why there's parentheses and then a bracket. Guys, in the past, you may also have written this as -infinity is less than y, which is less than or equal to 4. And that's the same. All 3 of these same things are saying the same thing. This way here is what you will have to use beyond Algebra 2. Our book does not, but we're going to use it a lot in this class just so you can kind of get a familiar. Look at standard form, which is ax squared plus bx plus c. Obviously, it's not nearly as easy to pull out the vertex when it's written in this form, but we are going to find a way that it's pretty easy to calculate. Okay, so anytime we're in standard form, I can easily find the vertex, or maybe I should say the x value of the vertex. Okay, it's going to be x equals -b over 2a. Okay, remember b is the coefficient for my x, and the a is the coefficient for my x squared. Okay, so after I have my x value, okay, all I would have to do is plug that x into the equation to get my y, and we'll do that here in a minute. Okay, so here in standard form, guys, we have 3x squared minus 6x plus 1. So if I want to find the vertex, we are eventually going to learn how to put this into vertex form, but it's a lot quicker if you just use this. Okay, find the vertex. My x is going to equal -b over 2a. Okay, well, my b is a -6, so -6 is a +6 over 2 times my a is 3. So this is just 6 over 6, which is just 1. Okay, so my vertex is going to be 1 comma something. Okay, now to find my y value, all I'm going to do is I'm going to take this 1 and I'm going to find f of 1. Okay, I'm going to plug 1 in for every x. So 3 times 1 squared minus 6 times 1 plus 1. This gives me 3 minus 6 plus 1. which is -3 plus 1, which is -2. So my vertex is going to be 1, -2. Okay, so 1, -2, here's my vertex. All right, now go ahead and find a couple points and plot this. So pause this video, find a couple points and plot it. All right, so when you graph it, you should see that this is like super, super tall and skinny. Okay, obviously I hope yours looks a little bit better than mine. But okay, now we're going to find the domain and range. Well, let's find the axis of symmetry first. Remember, the axis of symmetry is this imaginary line that we can simply reflect it over, or it's symmetrical about. Okay, and that axis of symmetry is always the same as the x coordinate of our vertex, which is x equals 1. So that's the axis of symmetry. All right, I know it didn't ask, but we're going to find domain and range. So the domain, once again, are the restrictions into the x values that we can find here. No, there's not. So our domain is all real numbers. Okay, you can also write this as all real x. You can write it from -infinity to infinity. You can write it, yeah, several ways. All real numbers, you can just write it out. Okay, my range does have a stipulation. Remember, my range is my y value. So when we're talking about up and down, this is as low as it goes. Okay, so my range is everything greater than or equal to, because it does equal to -2 right there. Okay, so if I write this in interval notation, it's less than or equal to, so I can use a bracket, and -2 is the least amount it goes, and then it would go all the way to infinity. And then there's a parentheses. Okay, or you can write from -2 is less than or equal to y, which is less than infinity. Okay, any of these are okay. This is what you will use in like college algebra and pre-calc and calculus. All right, so now we've gone over an example of vertex form and of standard form. So here's one of each. So I want you to pause this video. I want you to do both of these on your own. And then when you're done, unpause it and we'll go over the answers. All right, so let's see how you did. Okay, so the first one is obviously in vertex form. My A is the number out front, which is -2. My H is my 2, and my K is my 5. Remember, this is supposed to be a minus, which is why my H is a +2. Now, something I didn't mention in the video before is our A value determines whether we open up or whether this opens down. Okay, think this A value right here, this is a reflection over the x-axis. So if this is negative, this is what we look like. Okay, if it's positive, this is what we look like. Okay, so vertex is 2, 5. We open down because there is a negative, which is a reflection over the x-axis. My axis of symmetry is x equals 2 because the x value of my vertex is at 2. So x equals 2 would be like right here. And then to find my y-intercept, I simply plug in 0 for x, because when we cross my y-axis, my x is at 0, and I would get 0, -3. So when I plotted a few points here, my domain is all real. I know it didn't ask, but it's good to practice. And my range is anything less than 5. Okay, on my standard form here, my A value is -1, my B is -8, my C is 1. Because my A value is negative, that indicates a reflection over the x-axis, which means I open down. Okay. To find the vertex, remember, to find the x value, do -b/2a. And when I do that, I get -2. So the x coordinate of my vertex is -2. When I plug -2 in for x, I get 9. So my vertex would be -2, 9. Okay, my axis of symmetry is x is -2 because it goes along this x coordinate of my vertex. And my y-intercept, once again, we cross the y-axis when my x value is 0. So when I plug 0 in here, this is actually pretty easy because these will always cancel out. It's just the constant at the end. So I cross at 0, 1. If I were to do my domain and range, there's no restrictions on my x, so my domain's all real numbers, and then my range is from -infinity to +9. It'll never go higher than 9.